Welcome everybody to our ANH workshop number 30. We have today a special guest, Dr. Carlos Molinares, PhD, who is going to talk to us about the reservoir characterization for CO2 capture. I would like to maybe recall everybody what are our next talks, and we will have on September 23rd, we will have a special guest, Dr. Daniel Andres Rincon, a PhD, who is going to talk about the Rio Magdalena ROFI project. It's a land sea interaction of the major tributary of the Caribbean Sea. A very interesting talk. As you know, that is a project with the German government in the Caribbean Ocean, specifically in the Rio Magdalena area. And on September 30, we will have a special guest as well, Doctors Cesar Mora and Victor Ramirez, who are going to talk to us about the gas play fairway assessments in Colombia basin offshore and onshore with hydrocarbon commercial production. Well, we already have our program or chronogram for the talks on October. In October 7th, we will have a special guest from London, Dr. Andres Mesa, who is going to talk to us about global energy crisis and opportunity for Colombia. In fact, Andres is giving this talk this week in Europe, in USA, in UK. On October 14, we will have a pleasure to have with us Dr. Brian Frost, who is going to talk to us about the petroleum prospectivity potential and risks in the ultra-deep water Colombia basin. You know, Dr. Brian Frost is one of the experts in the Colombian basin in the Caribbean Sea. In October 21st, we're going to have a special guest, Dr. Karina Rodriguez, that works for Searcher from England. And she's going to give us an update of the saxing reprocessing that they are doing on the Sinú San Jacinto offshore. Very interesting area, new opportunities in that new reprocessing. And the last talk in October is going to be given by Dr. Carlos Molinares, who is our speaker today. And he's going to talk to us about the hard task of increasing production and reserves in Colombia, EOR, exploration offshore and onshore. Don't forget that we have in our website, the agency, are areas of identified with gas potential. So we have 30 in total at this time, and that number is growing day by day. So don't hesitate to access that information through the link that you see here on the screen. And there you can find the specific details of those areas where we can find gas in Colombia, gas and condensate. Well, it's a pleasure for the ANH to have Dr. Carlos Molinares with us today. Carlos is a geologist from the National University of Colombia. He got a degree with honors. He's a Master of Science in Earth Sciences from the AFIT University, and he's a PhD from the University of Oklahoma. He's the author and co-author of more than 25 academic publications and recognized speaker at technical events of the APG, SEC, UARTEC, HGS, CPs, and the ACGGP. Winner of the Best Speaker exhibition as a doctoral student at the annual meeting of the Geological Society of America, GSA Little Rocks in 2018. Colfuturo Scholarship from 2015 to 2019, winning of the J.P. Morgan and Ben Hart Scholarship during his master and doctoral studies at the University of Oklahoma. Dr. Molinares has more than 15 years of professional experience as a specialist in the conventional and unconventional reservoirs characterization, working for exploration, development, and new business teams in companies such as Ecopetrol, ConocoPhillips, Oxy, and Sierra. Dr. Molinari currently works as an independent consultant for ANH and or Universidad Nacional projects, professor at the University of La Gran Colombia, Bogotá, and host of the Energy Talks Ronnie Irani Center, or a space to discuss and study issues related to energy and energy transition. Well, before giving the word to Dr. Morinares, we would like to recall that we will have a very interesting talk next week titled the Rio Magdalena ROFI project, land sea interaction of the major tributary of the Caribbean Sea. That is a project done with the Arabic government and the Colombian government. Is going to be very interesting for all of you interested in sedimentary aspects in our offshore basins. Okay, Dr. Morinares, welcome to the ANH Friday Technical Talks. So, Daniel, please proceed.
Okay, one sec.
So, good morning, everyone. Good morning, Miguel, Daniel. So, Dr. Molinares is my dad. Normally, people call me Carlitos, but that's fine. So, thank you. First of all, thank you for the invitation. Thank you to the ANH for these talks. Are very interesting. I normally behind on Fridays listening. I'm very excited, very excited to be here first time to be presenting this topic that, in my opinion, there is a great opportunity for us as a petroleum engineers, geoscience, geologists in general. Can you hear me very well? Because I see some problems with my presentation here, but
no,
can you hear me?
Okay. Yep.
Okay.
Yep.
Can you see my screen and also the video? Okay.
Yeah.
Okay, got it. So, in my opinion, as I told you, there is a great opportunity for us, well, people with experience in the oil and gas industry, with this topic related with this carbon storage or carbon sequestration. That I want to talk today is a series of advances in US, especially in the US, about legislation and projects and the potential that we have to develop many of these projects or replicate many of these projects here in Colombia, in my opinion. So in the next slide, Daniel, please. So first is to say that, well, I don't want to say something that compromise my current employers or the ANH or the University of Oklahoma or any other organization that is going to be mentioned or institution during this presentation. So just blame myself no more. And this is the outline of the presentation. First, we are going to talk about the CO2 issue, about the Colombian emissions, GHG emissions. I know that I'm going to be talking to the choir, but it's important to remember the numbers where we are located now in terms of the global emissions. The third point is going to be about CCU is for you. It was called that way in the first AAPG convention in Houston, and I think it's important to emphasize that the CCU is really for people who has a good technical skills based on developed in the oil and gas industry. Then we are going to talk about the importance of the natural gas in this energy transition, what is important as well in many of these projects, CCU and CCUS projects, and in Colombia, why it's critical. So I highly recommend to attend to the next, by the end of this month, how you saw in the Miguel presentation, the presentation about the gas made by Cesar and Victor, because honestly, it's really urgent to increase the research, the production, and also the exploration in gas. And last one is kind of closures and remarks about this presentation. So I'm gonna start this presentation showing the map on the right, that you see what is the different countries and the percentage of the CCU emissions before the COVID, no, for 2019. As you see, well, and you know, it's very well known now and discussed in, you know, in different medias that our contribution is one of the lowest, and is less than 1%. Next, please. So when we start to talk about the CO2 issue, of course, it's because we have a negative balance. So it's quite similar to my budget today. When you have like a more expensive than earnings, so of course you have a deficit. So in terms of the CO2 budget, the problem is that we emit more CO2, or the planet with our contributions emit more CO2 that is that the CO2 can be sinks on natural ways. So now it's around 16, 17 gigatons per year, and approximately the 50% of the emission remain in the atmosphere. However, something that I want to highlight here on the top right is that the atmosphere is just the CO2 in the atmosphere is just a small portion. Probably you know that more than 78% of the atmosphere is composed by nitrogen, and a good portion, maybe close to 20, is oxygen as well. So in the next slide, it's good to remember about what are the most important GHG gases that affect our planet, is warming our planet. So on the left, you are going to see that the most important GHG is the water, is the vapor of water. It's not the CO2. The CO2 is just the 3.6%, and others are closer to 1%. But the point is that the highest GHG is the CO2. But there are others as well. There are others. There are other gases that also affect the climate and have a global warming potential. I want to mention here, for example, the methane, which is 21 times worse than the CO2, or the nitrous oxide that is more than 300 times even has a potential of more than 300 that the global warming you compare with the carbon dioxide. So the point is that it's important to know about the potential of the warming, because it depends on the emission that is going to affect the planet, and it's going to have an effect also in the warming. And also another point I want to mention here is about the average or lifetime in the atmosphere. Some of the reason we don't know too much about the water is because the water is only between 7 and 10 days in the atmosphere as a resident time. So it's really hard to get like a proxy along the geological period to get like a good idea, an estimation of how the water affected during the geological times the climate. And the next, please. But however, it's very complicated to deny. You know that the CO2 is increasing in the last years. Probably this is one of the most complete CO2 records, and is coming from the Mauna Loa Observatory in Hawaii. And you see that how from 2016 to now there is like a seasonal record, but it's clear that it's increasing. No, it's increasing the CO2 concentration. This is the record for probably the last 6 years, but it was more complete because it was recorded before as well by the Scripps. You know that this part of the UC's University of California, and when you compare from 60s, the trend is the same. You see the seasonal effect, but the CO2 concentration getting up, increasing. In the next one, when you see and you compare with probably one of the most complete ice core record of the CO2. Well, you see that the increments still there, and the red one is the previous slides. Is the red one in this plot represent the Mauna Loa Hawaii record, and you see that it's drastically the increments in the present, in the last couple of years. So that's very important. And also another point that is very to highlight, that we recognize that as a geoscientists, is that the effect of the dry and warm periods probably is going to be affected us, I mean Colombia as a country, and also the tropical area. So that you see there on the right is that in red the warm, and in yellow the dry weather is estimate, because the recent record of the carbon dioxide spikes. So that definitely is going to affect us. This is going to affect us. So we, in the next slide, we want to just to show about the different strategies that we can use to study these CO2 sequestration or CO2 storage alternatives as geoscientists. So on the left, you can use like the artificial CCUS or CCU2 storage by just doing the reservoir characterization work, like the similar path that we use to explore our reservoirs for gas or oil. And another way is just to understand how in the geological past the earth was naturally, in a natural way, storage of CO2. So I want to highlight on the right, for example, the Frasnian and Flammarion crisis, that it was the period that I completed my dissertation. And as you see there in this slide, it was a time where there was a drastic reduction of the CO2 concentration in the atmosphere. So, and the next one, please. It's just to show that the different paths or ways that we can use for the CO2 storage, or has a use, because the US means the use of that CO2, and we can use that CO2 for the direct conversion to using fuels, chemical or building materials, or no conversion or direct use, for example in gel boosting, solvent, heat transfer fluids, and others. Okay, so you can get further details about the putting CO2 to use in the International Energy Agency reports in the links in the website. So the next one. The next one is, I know this is based on a previous presentation I did for new grads and also students in Barranquilla. So I want to show here is just a comparison of the emission in terms of 1,000 CO2 1,000 tons, and you see where is Colombia in the last 10 years when you compare with Ecuador and Sweden as well. You see the increments in the Colombia and Chile records, but Ecuador is still increasing. But you see like a now negative trends in some countries like in Sweden, for example. So even our contribution is low. There are countries which are getting an opposite trend. So it's that we want in a near future, like Sweden, for example. In the next one, you see a comparison between the two bigs for Latin America. So for Mexico and Brazil, and you can compare with the previous Chile, Colombia, Ecuador, and Sweden as well. So you see the difference now. So but the next one is when you compare the big with the United States or China. Of course, our emissions are not significantly in terms of percentage, but of course we have a contribution, and we want to reduce that, and also we want to invert the trend that we are having during during the last years. Next. So it's very important to know about the CO2 footprint, and something that I learned after reading the Bill Gates book. It's something that you need to consider in different stage or different process. First one is could be something personal. Then it's gonna be then you need to think about your community or your school, your company, etc. And finally, you need to to think like a more global or initiative or something like that. So those are some apps that I found like a very cool to get like a trace of your personal CO2 footprint, because in the next one normally you have like also and you heard from your companies or other places that like some standards and some methodologies to get like your CO2 footprint. Normally that CO2 footprint methodologies are split in two. One group of methodologies that use like a single issue methodologies covering only emission and some impacts related with the climate change. There are a couple of examples there, but there are other methodologies that use they are used to determine it's called the PEF. The PEF are product environmental footprints. It's not just centralized or focalized in the CO2. They use like your footprint in the environment as a general, not just the CO2. So there are some decision trees that companies or institutions can use to get, well, which one can be better in my case, if there are sector initiatives, if there are sector rules, national or international interests. So it's something that is growing and is changing dramatically faster during the last years. Next. So I want to thank my daughter because she's studying probably one of the first carbono neutral schools in Colombia since 2018. So many of the previous slides it was based on her knowledge, honestly. Next. So something that is very important to know now is where we are and where we are going to be in the future, depending on our actions. So on the left, you see is on the axis the years from 2000 to 2015, and the y-axis is the GT-CO2. So now our emission just based on CO2 is around 36. And depending on the next years, with different scenarios, IPCC scenarios, we are going to have like a different, probably increments on the temperature. The ideal scenario that we want is of course, the net zero. That is the green one. That's that we want, because with that one, we are sure that the temperature in the planet are not going to increase more than 1.5 Celsius, because that the temperature or the increments that say, well, we are going to have like in a safe pitch, in a safe position. But there are other scenarios like SDS, which is a sustainable development scenario. There are others that the APS, which announcing pledge scenarios, which means that which are the scenarios that now countries and companies in general announce that they want they want to implement to get in a near future. But there is a really big gap, you see, between the APS and the net zero. There's still a gap there. And the steps is the steady policy scenarios. That means that just with the mandatory and the law that we have right now, without doing anything else, is the projection that we have in the near future together in 2050. Next. So in that, the previous SDS scenario, okay, is one of the contributions to reduce the CO2 is something related with the CCUS and CCUS industry. So that you see here is that in blue, all the projects or all the initiatives related with the efficiency, okay, how to do our process in a more efficient way, trying to reduce the CO2 footprint. In purple and red colors are all the initiatives related with the renewables that include wind, solar, biofossils, etc. And in the yellow, you see there all the initiatives related with the CCUS to get like a 9% of the emission. To get like the SDS scenario, we need to get like a 9% emission reduction related specifically with the CCUS. It seems like a small number, you know. Of course, the contribution must to come to different ways, and the CCS and CCUS is one way. Right now there are around 27 CCS projects in operation, without capturing 37 million tons of CO2 per year. But we need to increase that significantly in the next years, and you are going to see the scale of that in the next slide. This is where we are right now, with around 37 million tons CO2 year, okay? But to get the target in 2050, we need to increase our project in a rate of more than 25% years. That means by 2040, for example, we need to have more than 2,000 CCS facility operating. That require a lot of capital, a lot of capex. It's estimated that could be in between 600 and 1,200 billions. That's a lot of money. That's a lot of projects, a capital that we need to get in that. And for reference, you see also the land of the pre-pandemic 2019 global oil production to get an equivalent to that as well. So those are a summary of the projects that now are currently operating in US. It was an increment. Then after the 45Q tax credit timeline, you see that many of these projects are associated with the enhanced oil recovery. Some of them are saline, there are only a couple, or only one announced right now that I know, led by Oxy, related with the DAC, or direct air capture, okay? But you see the trend. You see the trend from 2018 to now, that the projects is getting up, and especially all those related with the enhanced oil recovery. But something that is, in my opinion, needed is the issue that we need like a series of tax reduction or a stimulus from the government. In the next slide, you see okay, you see the facilities now in US, okay, and probably one of the first facilities, it was if there are Texans here, it was in TerraGas plant in Texas, and the operation now of all these facilities in US are capturing more than 40 NT CO2 each year. but you saw the numbers. We need to increase in at least in 3 orders, significant orders of the efforts. Next. So something that is very important is just to characterize the hubs, the mission hubs for industries. That you see here is a slide, a map that shows where are the mission in the different part of the US, in the country, that they identify like a different hubs. In that hubs, they identify the different industries that contribute to the CO2 emissions. You see here they are a big hub related with the central part of the Kansas and Oklahoma, because there are a lot of refineries there, and also in the south part in Houston and Louisiana, you see. This is very critical because the CO2 shipped is just tested in small quantities for the use of the food and beverage industry. And there is only one reported the last month in Norway that is probably going to be the first transport of the CO2 in large quantities to get like a storage in the Norway seas. Next. But there is a lot of legislation. There is a lot of knowledge in US, especially, honestly, that to get an idea, for example, the Environmental Protection Agency in US control more than 740,000 injection wells. It's a gigantic number, And in US there are 3 different kind of wells. There are class 1, class 2, and class 6. But the class 6 are the real wells used only for permanent, for the purpose of permanent storing CO2. But you see, is in US a big industry with a potential that many of these class 2 get the transit to the class 6 in the near future, and many of the class 1 or other abandoned wells or new wells could be class 2, thanks to the new initiatives which were signed by the government, by Biden administration the last month. Next. So those are like this is very quickly. This is a tremendous fascinating period, because during the pandemic I was following the news and all the new reports in US, and how the government there, it was announced every probably 2 or 3 months a new initiative, a new budget or something, a new act related with the CO2 processes. For example, in 2020 Energy Act, it was created like they call it the Council of Environmental Quality. That council released the first report in June 2021. Then in November, they signed it. The President Biden signed it, like it was called the Infrastructure Investment and Job Act, that include a good portion of 12 billion over 5 years to carbon management and storage. February 15 in 2020, the administration released this fact sheet that you see on the part of that you see on the right, that I want to highlight there in that table, is that all the legislation and regulation behind all these projects, you see. And something I was very curious is on the bottom, you see something that is called port space ownership and mineral rights. So there are now legislation about local, state, and federal government that determine by the specific state and laws who is the owner, or who has the ownership of the port space. Okay, so I think that in the same way we had a great opportunity to learn things to interstate, intergovernment agencies. By the time we had a special interest in the unconventional, we think that we have also a high potential here to get to learn and to get like the knowledge and the legislation advance that they have in US to apply in the future in projects here, lead, for example, for the ANH, UGME, and other agency, Ministerio de Medio Ambiente, etc. Next. So it's very, very quickly the changes in the US. This is just to show you, it was last month, the last month that the President Biden signed something called the Inflation Reduction Act. It was a bill, it was an act that for reducing the inflation, but it's something important included in that act. It was the permit of tax credit for 430 billions. So the money is there, you know, the money is there, and there are companies interested in that, and there are companies that they are now doing the evaluation to get like economic results on that, and now they are apprised, as you see there in the paragraph, in the third paragraph, there is a price for the CO2 that is going to be provided for that tax credits. Okay, of course it's going to be higher for some projects like the tax project as well. Okay, next one. So the money is there now. There are also similar initiatives in the Canadians doing as well. In Canada, for example, and a disadvantage if you compare with the US is that the enhanced oil recovery is not included in that project. That's something that I don't know if that was in April. I'm not sure if there are Canadians here that know about some updates, but that's the difference between the US and Canada. That in the US, the enhanced oil recovery could be part of the tax reduction and tax credits, but not in Canada. Next. We have opportunities in Colombia. Yes, I want to present this one. Is from Yañez, ICP. He's working on the ICP in Ecopetrol in the Instituto Colombiano del Petróleo, and of course one of the critical areas of the best area where we can apply many of these CCUS and CCU projects is in the Middle Magdalena Valley, because we have a big emission there. So similar to the characterization that I showed you before, we know the refineries is there, the CO2 we don't need to transport, because the transport of CO2 is an issue in this economical issue in this project. So we have a potential there, but something that I want to mention about all these topics related with energy transition is that the most needed reduction are associated with the transport and the land use, that we also need increase the natural gas production. And to get some of the initiatives, we need even 4 or 5 times electricity capacity that we have right now. I heard, for example, in a presentation months ago that to get like all the electrification of Medellin motorcycles, we need 3 times the electricity produced by Hidroituango. So imagine that. Okay. Next. It's important to know that Colombia, okay, we need to do effort, we are in the way, but it's important to know where we are in the world, where we are, what kind of GSG we are emitting. On the left, you see our contribution in terms of the GSG, and probably near a half of the emission are related with the CO2, but 20% is associated with the nitrous oxide. And the nitrous oxide, as I told you at the beginning of the presentation, is even more have a more warming potential than the CO2 and more resident time. So that create a more warming and also for more time. And where the nitrous oxide is coming, normally it's coming from the diesel combustion, and also for no good fertilization and use of the land. So it's important to emphasize that there is important potential to get our contribution, and contribution that could be even cheaper than others, because it's not just the oil and gas industry and an extractive industry. There are other industries. Of course, the land use and land and the farmers may have a contribution and a very important contribution in Colombia. On the right side, you see other. This is another important number that I want to highlight here. On the with the green bars, you see the CO2 contribution normalized by people. So it's the CO2 contribution per capita. And only one Cuba, you see in that screen, only one Cuba is less green than Colombia when you compare these Latin American countries. So we are in the line that we need to reduce our contribution, but where? Which one are the cheaper and which one are more affecting more our planet in the near future? That's the question. And it is something that as a geoscientist, we need to communicate to the people and the agencies and the governments. Next. So that's kind of the intro, and now I'm gonna pass very, very quickly why that CCU is for you, and is part of the topic of this presentation. Why is it related with the reservoir characterization, and how does it relate with the natural gas? Next. So this is a slide from Cindy Gelding, VP America, in the first CCUS convention, and I like it, but because in that slide she described why this CCUS project is for you. Basically, because all the geoscience skill that we know that we have in the oil and gas industry are the same that are going to be used in all these projects, which we hope are going to accelerate in the near future. That include the basic modeling, stratigraphy and sedimentology, characterization, structural, geomechanics, data analytics, 3D and 4D geophysical monitoring, well planning, drilling, well testing, etc. So we know about it, and those are the skills that we need to develop that project. Okay. Next. It's also about to change the jargon sometimes, in the same way that when we, for example, I have the experience to work in exploration and then I move it to production. Sometimes you need this just to adequate your words to talk with the engineers. It's quite similar in this clean energy job transition. They are like a pairs when you compare oil and gas with CCS projects. In terms of reserve, store capacity, you don't talk about contingent resources. For example, you talk about contingent storage resources, and now the same companies that along the all the oil and gas industry were certifying the reserves. Well, they are preparing like protocols to certify the CCS and the CCUS process. Of course, there are potential jobs for us there as well. Next. In terms of geological trapping mechanisms for CO2, well, there are at least 4 mechanisms, but there are one that is more important than others, in my opinion. I don't know. Let me explain. So you see that the structural and stratigraphic trapping, the contribution is higher, and it's specifically higher during the time, if you compare the first time since the injection. So the CO2, the point is that CO2 is a problem that we have right now and need to solve right now. There are some initiatives related, for example, mineral trapping that could be very efficient, but the volumes and the timing of the trapping contribution is going to be later on time. So in my opinion, that projects which are emphasized in the same structural and stratigraphic trapping mechanism to trapping hydrocarbon and gas and oil are going to be more success in the near future, and probably are gonna get like more contribution, economic contribution by agencies in the near future. Can you dismiss that, please, on the reminder? That's this in this slide. Danny, can you dismiss the reminder there and on the bottom? Thank you. So this is just to mention one example. This is the Gorgon project. In the Gorgon project is probably the biggest CCS project around the world. Is in Australia. It's by far the big project because 40% of it represents in volume in the CC in CO2 volume the 40% of all the CCS projects. But unfortunately, they are underperforming in that project. And when you check that, it's something related with pressure management and water injectivity. Those are issues related with the volume group, and that means it's reservoir characterization, because by the end the CO2 is just another gas, and we know how to get the pressure, how to manage the pressure in a reservoir, and we know the issue related with water injectivity. We know if there are corrosive waters, we need to get like the prevention for that, and all these no technical well control in this project unfortunately create a problem for the companies operating this project in Australia, and now are estimated between 100 and 184 millions for get that shortfall in the CO2. Next. This is just to show you that in the similar way we get like a characterization of gases or oil PVT analysis on our reservoirs. Well, we need to do the same for the CO2. We need to know how is the variation of the CO2 with the different mix of brine and hydrocarbons in the reservoir, how that change with the temperature, with the pressure. So those are the skills that we know as a reservoir engineers, as a geoscience working in reservoir characterization. Okay. Next. And this clean energy job transition, the skills are again something that have been applicable for years, like sweep efficiency, the injection, terms like reservoir pressure, capillarity issues, CO2 leak detection. In the same way, we do like a seal analysis for our reservoirs and predict our reservoirs and seal risks. We need to do the same for the risks for the CO2 has a caprock or potential bracing during the enhanced oil recovery or just simple storage. Okay. Next. So this is a project in Norway. It's the Slipner project. This probably is the first one that started in 1996. The project in the west part of the field that contains clear near to 9% of the CO2, and that something that they do is just to inject in a very shallow saline formation, zero formation, the extra CO2 that they get from the production. As I told you before, probably the first and the most very well documented project And you see on the left is the workflow is quite similar to the reservoir characterization workflow that we apply for many of any of our fields, you know. And on the right, you see like the reservoir or the geophysical characterization and the seismic. And this one has a good advantage, you know, because it's very shallow. But it's the same that we do with our rock physics evaluations. You know, when you are trying to get like a evaluation of IVO or rock physics, we estimate our geomechanical properties, Poisson, ratio, geo models, etc. Next. Definitely that is gonna impact the employment growth and the jobs in the near future. As you see, there is gonna be a important decrease in jobs related with coal and oil and gas, but there is a good potential you see on the right in millions of jobs in new energy transition industries like the hydrogen, bioenergy, and you see in red the increments related with the CCUS project as well. So in that is very important. The natural gas as a energy transition in the energy transition projects. So on the bottom you see like the different IPCC scenarios, the steps, the APS, and the net zero. But something that just I want to highlight here is that the gas with CCUS. So we need to get a production in gas, natural gas, to get like the energy and the storage, to get a storage of these CCUS projects. And also related with the electrification and the electricity. Okay, because you know many of the new technology projects like the hydrogen needs the natural gas as well. This is a projection, a comparison of the different projection of the natural gas that will power the energy transition. Those are prediction made by the IAA in 2020, and how that is showing just the coal and the oil. The coal is going to reduce drastically from now to 2015. The oil is going to be kind of stay, but the natural gas is getting up. There are, of course, a good portion is going to be related in this transition is going to be related with the new technologies and renewable electricity, but it's not going to be the same growth in all of them. You see, the solar and the wind will have, according with the same agency, a better growth when you compare with geothermal or a hydroelectric industries. Okay. And on the left, you see, you see how the nuclear, coal, hydro, so there are no significant increments related with that. Okay, next. So this one is just to show the importance of the gas, how that is affecting Mexico particularly. So on the left, you see like the cold snap in Texas, North Mexico. So you see how now in US is basically selling to Mexico the gas that they needed, because they have like a positive balance between the import and the production, import, consumption, and the production. So but the point is that, okay, we may buy the gas to others, and then Mexicans know right now, you know, okay, I may develop by myself, or I may buy to others, US, Qatar, Venezuela, whatever, but the prices are gonna be international prices. And you see on the right how is the trend of the different prices, gas of natural gas in different markets. You see the blue spike there. It was the crisis in Texas during the last year during winter, and the price was close to the 25, the BTR. And you see also the pricing in other facilities and in Europe and North Asia. Okay, so I think it's not a good idea to depend on the gas, import gas, when you have the potential to develop in your own country. And those are to show you how is the LNG export liquefaction terminals grow in US, and how all these gas export infrastructure is growing toward Mexico, because unfortunately Mexico now they are in shortage of gas, and there is a ban as in Colombia of develop all the resources that they have in the north part, because you know there they have like a basically the extension of the Eagle Ford play. They have it there, but they are banned like the unconventional projects. Next. And in case of Colombia, you see that it's going to be critical for the next months. So you see, you can compare the scales there are the same in terms of the GBTUD, and probably in the point is where we are going to have our next Nino event, because if we have like a Nino event, like it was projected by URME in the middle part in between September and May 22nd, so the middle part where you have a peak there. Unfortunately, we haven't now. But when we are going to have the next Nino, and with the next Nino, we are going to be in negative balance. In a negative balance means that we need to import, and we are going to import with international prices. So to remark, the CCS and CUS is an emerging topic with a great potential opportunities, employment opportunities in the near and the long future. We need to get like the SDS scenario, more than 2,000 CCS facilities operating by 2040 to meet that 90% reduction in the emissions associated with the CO2 storage. Okay, the technical skill and associate skills related with the enhanced oil recovery, reservoir characterization, gained in the schools by oil and gas workers, and also new students, new hires, will be also applying the CO2 projects in the near future. So it's good to get back to the basics, especially in the reservoir characterization, because we are going to need it to avoid problems as the operator had in Gorgon project in Australia, for example. So where to learn about CCU and CCS? Next, please. Of course, in the books, in journals. I really highly recommend the Bill Gates book, because that gives you a good perspective about the numbers, you know, and the future, and why it's important. All these the CCU and CCUS and other topics important in terms of the energy transition. CO2 carbon primes is a very important issue as well, mentioned in that book. Next, where to study? Of course, there are a lot of good schools around the world, in US, in Europe, Australia, in Canada. Okay, all these schools have some special programs now oriented toward this topic. In events, okay, conference, as we have in Houston. Image had a special session for the CCUS last week. Yep. So last but not least, well, I'm very optimistic, you know, because when I was in the high school, the coco, we say in Spanish, the coco. So the problem, the big problem for the humanity was the issue related with the ozone break, you know, with the ozone hole, and we did it, no? We did it. We tested and we reduced significantly the production of the CFC and HCFC, or these are gases that affect the ozone layer and created the ozone hole. So I'm very optimistic that in the future we may have similar, you know, figures like this one showing that we reduce our CO2 emission as well. So again, thank you very much to ANH, Miguel, Daniel, all the attendants for the time. This is my page in LinkedIn. In case you have more questions, you want this presentation, please don't hesitate to contact me. And it's also a non-paid announce as well, and publicity that please follow us in our YouTube page from the Ronnie Key R&D Center for Energy Solution, where we discuss normally bi-weekly this topic related with the energy transition and energy topics. Okay, so thank you, Miguel, thank you, Daniela, to the audience, and I think that if there are time, is the time for the question.
Thank you, Carlos, for this amazing presentation. We always have time for the questions. So if any of the attendees have any question, just write it down in the chat window and we will read it for Carlos. And I'm quite sure that he will be quite glad to answer it. Meanwhile, I'd just like to remind to all of you that next week we'll have our ANH workshop number 31. Our special guest will be, the presentation will be Rio Magdalena, the ROFI project, along the interaction of the major tributary to the Caribbean Sea. It's given by Daniel Andres Rincon, PhD. So we are open. You got any question for Carlos about the CO2 storage, the CO2 emission, and how we can address that sort of problem as geoscientists and as geophysicists, geologists, and engineers? We'll give a minute if no one has a question. So we'll thank Carlos for this great presentation and for being available for us into the ANH.
Thank you, Daniel.
Okay,
thank you all
Carlos,
the attendants.
it seems that no one has a question. I'm quite sure that the presentation was quite straightforward, quite clear for everyone. So thank you, Carlos, for your time. It's been nice to have you here at this space. And thank you to all of the attendees. Have a nice weekend.
Have a nice weekend. Thank you.
Bueno, muchas gracias.